We are now live. Morning, everyone, and welcome to ACDE 161. So I guess today, if people have any more thoughts or discussions we want to have around Cancun's scope, we can do that first. Then it probably makes sense to spend most of the call talking about implementation for the current Cancun stuff, and specifically for 4844, there's a bunch of open issues that I've listed on the agenda. And at the end, we have Zach on, who wants to talk about an kind of a funky EIP because it would only apply to L2, and whether this should even be part of Alcor Devs is an open question, so we can go through that towards the end. Yeah, I guess to kick us off on the Cancun stuff. So on the last call, we sort of agreed to include a bunch of EIPs. So 1153, 4844 was obviously included. This SSZ optional EIP, and then the self-destruct removal. We also CFI'd a couple more. So the BLS precompile, the beacon block root, and the SSZ transaction signature scheme. I guess, did any of the clients feel like I have any updated views on that, like anything that they think we should be considering, or yeah, I'll pause here. Otherwise, it's fine to keep it as is and keep going with that. Okay. Sweet. So we'll leave this as is, and I assume based on the SSZ conversation, we might make some changes. If not today, then maybe in the next few calls, or at least changing the actual specs. Okay, so next up, actually, sorry, just before we wrap up here, I guess I'll assume that by default, we sort of keep this scope for Cancun, and if anybody wants to change it going forward, just put something in the agenda or on the ETH Magicians thread, and I'll pick it up from there. But this way, we don't have to go over this every call. Okay, yeah, and so next up, 4844. So there were a couple open issues or concerns. So we can just go through them. First, Andrew, you mentioned the difference between the input and inputs in the precompile being Little Endian versus Big Endian. Do you want to give some context on that?
Yeah, sure. I think the Little Endian encoding was inherited from CL, or was just taken from CL, and on the CL side, things are Little Endian, but now there is an inconsistency, and on the EL side, in the EVM, most things are Big Endian. There are kind of some inconsistency. I think Blake 2 precompile might have some inconsistency, but most things are Big Endian. And now we have this weird situation where Z and Y are like the two inputs. I'm not sure about the rest of the inputs, but at least two inputs are Little Endian, while the outputs are Big Endian of the point evaluation precompile. And I'm just thinking we can be okay with it, but maybe we should just explicitly clarify it in the EIPs that it is that we do have this inconsistency. Or I don't know, what are the views? Or we might want to reconsider this.
Does anyone either have a strong opinion on this or like a rationale for why we should keep it this way?
I think the output is kind of mostly for informational purposes, the output of the precompile, so it's static. Maybe it's not too big a deal, but so if we leave it as is, I think we should just add an extra clarification to the heap that we just highlighting the inconsistency.
Okay, and there's some comments in the chat from, I think, all the other CL clients saying they don't like Little Endian on the EL.
So I think we should have a really good reason to have the inputs little endian. Otherwise, we should just make it big endian.
I think if there's any border or transition between little endian and big end, it should be at a high level as possible. And what we're talking about is way too low level to make that affordance.
Okay, so this and yeah, there's like plus ones from all the EL teams on Maris's comments. Should we just make this change to the spec then? Put everything to big endian, and that means everything on the EL stays little endian. Oh yeah, Ethan has a good question. Does this affect some of the underlying crypto libraries if we switched everything to big endian?
I think it can read inputs in both big endian or little endian. You just have to specify which.
But does it convert twice? Because usually the libraries have like a native order that they prefer to operate on.
Even if it converts, so it'll read the inputs in its native representation. So there might be some conversion, but it's a very fast operation. It's negligible compared to the main runtime of the precompile.
I also think we shouldn't take the time for the conversion into account when making this decision. This is more about if for some reason all the inputs that are going to be into this precompile are already little endian, then it would still not really much for me. It wouldn't make that much sense to have it little endian, but I would see the point. I don't think execution speed should be a consideration here. Like the big endian to little endian conversion is so fast, that makes no sense. But if there are if there's a really important issue why we need this, then I would accept it. But from my point of view, I have no idea what the authors thought about. So I would just go and say, let's make it big endian as everything else.
Okay, does anyone disagree with that?
No disagreement per se, but we should check whoever created the spec. I mean, there must be a reason why. It's just because we can't say why it's little endian doesn't mean there's no reason.
I mean, Dankrad, I believe is on the call. I don't think Prolo is here, but Dankrad, do you have any thoughts on that?
Sorry, just joined. I didn't get the context just now.
Is there a reason why the precompile in 4844 uses little endian? And would there be a problem if we converted everything to big endian to just be consistent with the entire rest of the EL?
Oh, I see. All right, that's a very good question. Yeah, I mean, this is like a difficult one because we are like starting to switch. Yeah, like the CL, everything is big endian. Yeah, I don't know. Honestly, I think I don't know how much we thought about this.
Okay, so yeah, so there's no reason within 4844 why it's like much better to have the inputs be little endian. It's kind of a default design on the CL that's sort of.
Yes, I mean, I guess like there are two things, like the CL is big endian, but also crypto libraries tend to be big endian. So I guess, oh, they tend to be big endian. Sorry, so it's actually the opposite. Yeah, it might actually make more sense than to make it big endian, also because the EL might do some computations in using those integers. Yeah.
Okay, and I don't know if Proto's on the call. No. So I guess what we can do is at least we can open a PR on the EIP to make it big Endian, leave it up for a few days for, if Prolos, the other major author that's not here, or if anyone else has objections, they can obviously raise it on the PR. But assuming that there's no objections, we just move it to big Endian. Mikhail?
Yeah, as far as I can see, the spec for a spec refers to a verify KCG proof function that is defined in the on CL, which is little endian, I believe. So that's probably the reason for
Sorry, which function did you say?
Verify KZG proof. So the precompile as it is specified calls to this function, and this function is specified in the CL spec. And CL spec is little endian, I believe so. So that's why it is specified this way. I mean, like this why inputs should be little endian to be aligned with the CL.
And I guess otherwise we would have to do this conversion in the engine API or something like that.
But what's the output on the consensus layer? Is it also big endian?
There's no output. I think this is insertion, right? It just asserts that the verification is correct.
Yeah, the output is fixed, and it is specified in the currently that the output is big endian. So that's why it's inconsistent at the moment.
So I don't think the CL directly calls verify KCG proof, right? It does the blob verification, but never verify KCG proof, as far as I know. So it's fine to change that function, but I mean, it is going to be a bit weird because now the KCG library will have both big endian and little endian interfaces.
Right. And I guess the question is, where should those, if we're using big endian somewhere, little endian somewhere else, we're going to need to have both interfaces somewhere. And the question is, where's the least awkward part for that? And I guess the argument from this EL folks was that it is really weird to have this as part of a single precompile input and output on the EL. I guess, yeah, if we can at least put up the PR to propose the change and, move the discussion there in the next couple of days, that would be good. There's a 4844 call on Monday if we want to talk about this in more detail, or if there's any sort of objections that come up in the next couple of days. But it seems reasonable to at least draft this spec and take it from there. And I guess if there's no strong objections, just merge it in the PR, merge it in the EIP. Does anyone want to volunteer to write that PR?
So just to understand this one, if the PR gets merged, then we definitely need to change the KCG libraries. But does anything else change? What else changes to do this thing?
Why would you need to change the libraries?
Because my understanding is that we're talking about the input output of verified KCG proof, which is what the library does, or am I off topic? What is it?
I think that it can be spec'd in a way that, okay, so we do a conversion from big endian to little endian, yeah, but that will be a bit of an overhead. But it can be spec'd out in this way to emphasize that verify KCG function is little endian, I mean, like accepts little endian inputs. So I don't know, that's one of the ways, not necessarily change the libraries, but just change the spec. It depends on how do we want to handle this.
Okay. Oh, Andrew?
Yeah, I was just thinking, so we can add a parameter to that function that passes the inputs or whatever, like verify. So basically, parameterize the function whether it's a big endian or little endian, and then explicitly is set it on the EL side. And I was thinking about the Blast library. So Blast library can do both. But maybe in a like on top of Blast, the libraries might have to be. We might need to change the intermediate libraries besides Blast, the KKZG libraries.
And I guess, yeah, so even if we need to modify the libraries a bit, do we still think it's a worthwhile change?
Well, I think it just adds clarity because so if you have that like little endian parameter as an extra explicit parameter to the function, then it's there is no ambiguity. You see it. Okay, in my definition of the precompile, everything is big endian, and it's explicit because right now it's as it's specified. It's not immediately obvious that there is an inconsistency because that function is defined on the CL side, and without like that extra knowledge that everything is CL is little endian, then you don't just reading the EIP, you don't see it. You don't see the inconsistency. With the explicit endian argument, everything is just more explicit.
Okay. Any other thoughts?
I think the important part is actually like how are contracts going to use this? And if the smart contracts are going to use big endian in everything else, and they now need to do the big endian to little endian conversion in their contract to call the precompile that does this conversion in reverse, then that's kind of bad, I think. So we should make sure that whatever we choose it into accordance to the people that call the precompile.
I do agree with that. I think it hasn't been given that much thought. One thing that is going to be interesting here is that obviously the group elements are also in theory, like, I mean, they're large integers. I guess like they are kind of compressed according to the BLS standard, but it's also potentially possible that in the future someone would want to do computations with these, especially once we have BLS precompiles. But yeah, I agree that for the field elements, yeah, it does seem to make much more sense to have them be big in the end.
Okay. Yeah, I think it's worth at least making the suggestion in the EIP. So Gajinder said he can do that, and kind of moving the discussion offline and getting more feedback on it before we merge it in. Yeah, does that make sense to everyone? Okay. Okay, next up then, so the big thing we discussed over the past 2 weeks was what to do with SSZ on the EL as well. Um, there was a bunch of issues trying to get the libraries working and some quirks of SSZ on the EL, and then Matt put up a PR to show what it would look like if we just use RLP instead of SSZ for Forward 4.4, and Xiaowei put up a PR on the CL side as well to kind of show the impact this would have on the CL specs. And there was some recent conversation on that second PR. So I guess I'd be curious to hear, from teams, what do people feel is the best path forward at this point? Should we move the EL transactions to use RLP? If so, what can we do on the EL or on the CL specs to like minimize the pain of bringing it in? Yeah, and I know Light Client, POTUS, Danny, you were all chatting about that on the issue in the past few days. So if any of you want to share your thoughts, yeah, that'd be good.
Yeah, so there's definitely a desire not to have RLP as an explicit dependency on the consensus layer for more than one reason. But so I think if we did go this path of RLP as the blob transaction encoding, we would want to do something like Matt's proposal. But I think Matt's proposal mentioned that to put these version hashes in the blob sidecars. Instead, I think that what we think makes sense is that they would be, some sort of adjunct list inside of the actual block body. We want to have the requirement that the block can be executed on the consensus layer and the execution layer without having the blob sidecars on hand. And so we would shove them into the block body. I think that's kind of in line with the proposal. It is a bit more of a breaking change, but this is a breaking change. So I don't think that's a showstopper. Does that make sense?
Yes. Andrew?
Yeah, I was just thinking again, and to my mind, the current situation is not too bad, because the main concern with the current spec is that we are going to have a different SSD format for transactions. So we will have to change the current the blob transactions into something else. But on the other hand, we are going to do the same if now we revert back to using RLP for blob transactions. Then I think Mario's told that with that, blob transactions will be temporary, and when we figure out how to do SSD properly, we kind of introduce a new type for blob transactions, which is proper SSD. But then again, if we are doing that, then having this temporary SSD transaction type for blob transactions, again, it's on an intermediate solution, and on the upside, we don't have to introduce RLP into CL and so on. So I kind of currently my thinking is that the current solution is not too bad, the current spec.
So I hear you on that. The main question is, okay, if we're going to have to change it, do we want to introduce a very limited additional SSD dependency on the execution layer that might ripple outward into, potentially how L2 wallets and other things utilize this? So it's the question of, if we're not going to do it right, should we limit the dependency addition through this other mechanism? The nice thing about the method on the consensus layer that was proposed by Light Client is that it actually makes whatever the encoding is of these transactions, whether they change in the future, kind of transparent to the the execution, the consensus layer. Like the consensus layer right now can't really read transactions. And this is like we have this exceptional way to try to read a component of these blob transactions. And by going down this path, it makes it so that the consensus layer doesn't have to read these transactions, and that the validations that have to happen occur on the execution layer, regardless of the encoding. So it's a nice generic way to do it regardless as well.
I also just want to be very wary of introducing changes that we think are intermediary. We don't really know when we'll be able to make the full change. We don't know what the full change is going to end up looking like. And I think we've seen in past forks where we try to do something that's forward compatible and it ends up not being as forward compatible as we want it to be. So that's kind of why I feel like if we're not going to go full SSE and like find the right solution now, it's probably best to just stick with what we know, which is these RLP type transactions, and continue thinking about how to do SSE later.
There's a question in the chat around like, why don't we think like Ethan's latest EIP is doing SSE well?
Which one?
Yeah, I don't know, Ethan or Roberto, do either of you want to give context on that?
I guess he's talking about 6493 for the signature scheme, or 6404 overall. I'm not sure which one.
Yeah, I mean, I think 6404 is definitely approaching, what we want to do with SSE, but it doesn't really seem like there's appetite from the other developers to try and pursue this for Cancun. I generally think that like that's what we want to be looking at doing for SSE, but like what is in the proposal right now is not there. And like specifically, I think taking the hash of a serialized SSE value is not the idiomatic way of hashing SSE objects, and it just doesn't make any sense.
So I was speaking of 6493, which I think is compatible with 6404.
Yeah, but it's just for the signature scheme, and so it really provides no value to users. The only value it provides is maybe not having to change the signature scheme in the future, which helps us avoid, potentially breaking or making like hardware wallets change how they compute the signature hash of the transaction. So it doesn't give us any of the benefits that we like are looking for in SSE.
One benefit that it gives you is right now, if you use this flat hash function that just takes the serialization and then hashes that one and you sign that, you don't get any benefits from SSE for this transaction type. But if you use this idiomatic approach of the hash tree root, what you gain from it is that the hardware wallet can, for example, display certain fields, like you can send just a part of the transaction to the hardware wallet and it can verify that those parts are actually included in the hash that it is signing. That is not possible with the flat hash. For that you need the tree structure, right?
Why would you not send the full transaction to the hardware wallet?
If you are sending the full transaction, then why use SSE for the transaction?
That's what I'm saying. I don't think it really matters that much for the signature hash, because for you to verify the signature hash is like what you expect. You need all the elements anyways.
Can you send the full transaction? Isn't it like pretty big?
I think that's how all hardware wallets are implemented. Like if you just send the hash, then you don't actually know what is behind the hash.
No, I mean like the hash plus Merkle proof of individual fields in the transaction, so that you can, for example, check the destination, but you don't have to send all the blob contents. I'm not sure if that's useful or not, but it's possible with SSE.
The blob's not hashed though. The blob is a KZG commitment. So likely the transaction going into a hardware wallet would just be the fields plus the KZG commitment, not the blob.
Okay, yeah. Now then it makes sense to just send the full thing. And I agree that, I mean, it depends on the overall thing of this union thing or the normalized transaction, this bigger thing, right? But right now, the 6404 has this conversion step where it just takes the mempool transactions in whatever format they are on, and then it converts them to a normalized representation when it is building a new block, right? So for that EIP, it doesn't matter how it looks before. We could even add like CK commitments to it as part of the conversion. But yeah.
Also, it was argued before that hardware wallets won't actually be doing SSD blob transactions because this is mostly be gonna used by L2 sequencers.
I still think L2 sequencers probably would want some sort of hardware solution for signing transactions, even if it doesn't exist yet.
Yeah, agreed.
And I think the code ends up being pretty similar, whether it requires manual input like a ledger, or if it's some sort of like, other hardware like key mechanism where the key is just stored there and you're sending requests to it online.
Yeah, I still want to make the case that going down the path of what Light Client suggests does make this much more future compatible, such that if and when the transaction type changes on the execution layer, the consensus layer doesn't really have to know about that, but just changes the validation of these version hashes that come in through the engine API. And if we're going to go that path, which I think is more generically future compatible, doing the least invasive thing on the execution layer would be my suggestion, which I think you can make a strong case that RLP is that, but potentially you can make the other case, given that at least SSE exists today in the test.
Okay.
And could you share the link to this proposal on the CL side? Oh, is it in the agenda?
Yes, it's like basically a comment though. Let me, yeah, it's like the first comment on Xiaowei's PR basically. And then Danny, and basically
essentially we have to pull out like the version hashes from the transactions, which are otherwise opaque to the consensus layer. And so we were doing that by using offsets for the SSE. If it's RLP, we would have to integrate an RLP library to do the recursive lookup. And then we have to make sure that those version hashes are actually the hashes of the commitments that we expect. Instead, we could make those version hashes an explicit component of the block. And when we pass them into the engine API, such that the execution layer does the check that those version hashes are actually the ones that are inside of the transactions. And then we can do the higher level check on the consensus layer and not have to worry about the encoding of the otherwise opaque transactions. It sounds convoluted. It's moderately straightforward and prevents having to do any sort of like peering into the user transactions on the consensus layer.
Andrew, I don't know, is your hand newly up?
Yeah, I'm just thinking aloud here. Like, would it be too much to just do 6404 in Cancun? Because it seems to me that it's the direction we want to go. So maybe we should just bite the bullet and like implement proper SSD with blob transactions.
Across all the transaction types, right?
Maybe.
6404 is changing all of the transactions to SSE and removing the Merkle-Patricia tree root for the transactions and making an SSE root.
What about legacy transactions? Because there are like plenty of hardware wallets like that will never change.
Right. It just changes the formatting that goes into the Merkle-Patricia trie. It goes into the SSE root, and the signature scheme, the signature hash of the legacy transaction stays the same. So the hardware wallet still sign the legacy signature hash.
Right, I see. Oh, okay. So it seems to me it's the direction we want to go, right?
I think so.
Alexei?
It's kind of new idea, but probably it is possible to separate old transactions and new transactions. So we do not need to invent something new for old transactions to be to become a part of Merkle tree. Instead, we could have them separated and marked as deprecated. So we will have clean SSD solution and RLP part, which is marked as deprecated, and then we will not allow these legacy transactions in the future, but after some time, and we will not mix these parts somehow.
Well,
I think
it's
that
not a bad solution because hardware wallets, like we cannot make them obsolete, and
Why?
so. But I
You
think
could,
the new EIP like 6400 it takes it into account. It just introduces a backwards compatibility layer, which is nice.
but we will have RLP all the time after that.
I think that's not the problem. It's always the problem that we have different transaction route between CO and DL. I don't think that like having RLP on the L side is a problem.
also having two lists of transactions seems to complicate block production a fair bit. You start to get to a point where, if you're a MEV builder, you're trying to extract value from transactions that are at the end of the legacy transaction list, and maybe you want to put your transaction at the beginning of the non-legacy list. It just doesn't really seem ideal to have two ordering mechanisms now.
Well, you may have, okay, we have ordered transaction list in Blob, right? We just can put one of them into root, another into another root, and it will be like two local orders, but we will still have it, the global order, aren't we?
Yeah, I'm not sure. I mean, maybe we can have a global ordering still, but we talked about this a bit in Austria, and it didn't seem like people wanted to have two transaction routes. Maybe I'm forgetting other reasons why.
Matt, is the question to have two transaction routes, one for the block transactions and the other one for the legacy transactions?
I think, yeah, basically, but not just for Blob transactions, for SSD transactions, which happen to only be Blob right now.
Right. So I was using this for a different reason, which I would love if there's a discussion at some point. It's sort of tangential to what is here, but the point is that it would allow to have separate PBS separations so that you can still propose a block built locally and use the builder for block production. And I think this is something that we may want to have.
We can at least find some okay hardware wallets. Well, we cannot deprecate, right? It doesn't seem okay that we can like have this legacy all the time. Maybe we could at some point get rid of all transactions.
Yeah, I mean, maybe like have a precompile that accepts a legacy transaction RLP and signature and instantiate hit transaction there. Like that's kind of been what has been thought about for totally getting rid of these legacy transactions, but then you start introducing a concept of sort of initiating a transaction with an EVM execution, and there's just like things that haven't really been thought fully through yet.
And I guess if we were to do like a full SSD transition in Cancun, these are all the things we need to figure out before that, correct? Like, especially if we're saying that the value we get from doing the full SSD transaction now is like we don't have to change it again. Whereas right now with Forward 4.4, we just have a single transaction, which we might end up changing.
Yeah, that's kind of what I would hope for in a quote unquote full SSD transition. That's not to say that we have to solve this like transaction in a bottle situation. Like I think that having the legacy signatures is generally okay. That's something that I don't think really comes into play as an issue until we start doing, ZKing of all of the transactions in the block. And you might not want to have any RLP, but for today, as long as they're represented as SSD in the transaction route, that is the main thing we're looking for. But I guess there's still questions about should we have separate transaction tree for the blob transaction so that you can produce things locally. I don't think that this is necessarily relies on SSD. It's just like another arc to go down.
Yeah. And I'm curious, like, do people feel like it is reasonable to potentially figure all that out for Cancun? Without basically massively delaying Forward 4.4 or everything else.
I feel like we had this conversation and we keep saying it would massively delay, and there are a lot of uncertainties, and it's like a can of worms that will likely take months. Potentially that is less than months now because people have been thinking about it for a while, but I don't know. I do think that we keep asking the same question, even though we presumably made a decision on it.
Right, and I guess the point we're at is like now it seems like the alternative is we move to RLP on Forward 4.4. That's also a non-trivial amount of work, but at least it seems like work that we like have a really good understanding of. Yeah.
Yeah, I feel like we're kind of at the point where we need to say we're going to go with RLP, or we're going to say, okay, let's just sit down and be a little bit more serious and comb through 6404 and figure out what needs to be changed and what the exact world of like SSD transactions is going to look like. Because I don't think a lot of EL teams have gone through it deeply.
And yeah, I guess I'm curious, like I'd love to hear from other EL teams, like, do you feel like it is something you have the bandwidth to like go through deeply in the next, I don't know, 2 weeks to a month? And I think if not, then it probably makes sense to either keep what we have now, but that seems like the worst of all worlds, or use the RLP scheme so that at least all the transactions are consistent.
We have capacity to go through it.
Okay. Anyone from Besu?
Yeah, it doesn't seem like too much of a challenge for us, frankly.
Okay, and so
into SSD.
I'm sorry, say again?
Which part isn't a particular challenge, converting everything to SSD?
Sorry, the RLP adoption.
Okay.
Let me rephrase. taking the existing SSZ implementation as it exists today in 4844 and reverting it to use RLP would not be terribly difficult for us.
Right. To be clear, the question though was, do you have the bandwidth in like the next month or so to think about a wholesale move to SSZ? Like if we were to go down that road, I feel like we need to, hash out the design in like the next month. And so is that like realistic?
I think a month is a little less realistic, but 6 weeks to 8 weeks is more realistic.
Yeah, Danny?
And just to contextualize, if it's 6 to 8 weeks, then it becomes implementation, which then probably surfaces additional details.
Yeah.
That weren't previously discovered and has at least a few test nets, or at least a couple, to kind of like go through those iterations. Just to, it's okay if that's a decision being made. I just want to contextualize that's.
Yeah. So to
6 to 8
elaborate,
weeks doesn't mean and then it's done.
Yeah.
Right. So I'm actually considering two things going on here. One, the actual research and thinking through that Light Client is suggesting, but also our implementation of SSZ right now is very, very thin and very, very specific to a lot of the things that the CL has already adopted. And there are a number of gaps there that need to be revisited and implemented. Things like, new data types like optionals, the way that collections and lists are nested, etc. So there will be some upstream work that needs to happen on the libraries that we use for SSZ.
I thought we already had this discussion around whether we tried to do a more thorough SSZ conversion in the L and dismissed it as pretty impractical. It seems odd we're revisiting that. Seems a little crazy to me, to be honest.
So but I guess my point is welcome to Alcordes. If we are not willing to revisit that, then to me that's like a pretty strong signal we should just do RLP and properly take the time to revisit SSZ. It seems like the current spec is like the worst of both worlds. And I'm fine with that, but it seemed from the discussion 5-10 minutes ago that others weren't.
I don't know. I wouldn't call the current spec the worst of both worlds. I think the issue with, say we did a 6493 and we went with that. I think the concern is that we missed something and we just have to introduce a new format anyway, and so all the work we put in SSC might not be as valuable.
I think the biggest concern is introducing a little bit of SSZ and then never being able to introduce the rest of it. And then forever on the EL, we have this one strange transaction format with a strange signature scheme that's totally different than everything else. That to me is like the biggest concern.
I guess I don't see why introducing one SSZ type now would make it harder to introduce full SSZ in future.
I'm not saying that it would make it harder. I'm just saying that there's always a large risk of doing any kind of change to the protocol, and I don't want to try and implement something with the expectation of changing it in the future.
Right. One example would be if you so in order to introduce SSD, we need to introduce SSD signature scheme for the Blob transactions, and for example, we need to figure out optionals and a few other stuff. If we miss something or some of this work will not be fully compatible with the work needed to basically switch everything, and then all of a sudden we might need to swap out the SSD signature of Blob transactions to once again, and then it's going to be super messy. I mean, yeah, everything's doable, but
Andrew?
I think the current spec it's okay-ish because the signature, what we sign in Blob transactions, say like how SSV works. That the first field is this chain ID, which will always be 0, 1, like 1 in the little endian form. So 0, 1 and 0, 0 bytes. So it doesn't clash with RLP. It's okay because of that peculiarity. I don't think that we need to even going forward. I don't see a reason to introduce kind of any complications to signing transactions, because presumably SSD, all SSD transactions will start with a chain ID, so there will be no clash. But even if we do change that signature, it will be only for blob transactions. Guess no hardware wallets, not a big deal. So I kind of think, yeah, it's okay.
I don't know. Anyone have? I guess, yeah. Does anyone still think we should do the full SSD investigation now? Let's start there.
What is full SSD?
So
You
basically,
mean
consider 6404, like, yeah, yeah. Consider 6404 for Cancun, which will probably be like a relatively big exploration, and likely will delay things a bit. So yeah, I guess I'm curious if anyone still thinks that's like the best path forward. It seems to me like no, but it's hard to gauge. And then if not, is it better to keep the spec as is, even though it's a bit hacky in a way, or should we just do the work to get it to RLP so it's a bit more upfront work, but at least we have something that's kind of compatible or aligned with everything else on the EL right now? And I guess it's also fine if we don't make that decision today, but it does feel like we're kind of bottlenecked on this for a lot of 4844 progress. So if we are going to decide to switch everything to RLP, I think it would be slightly better if we made that call today and people get an extra 2 weeks to work on it. But another option is as well, like sort of fully specking out what Light Client has in the comments and with the changes proposed by Danny, and maybe we can like make a call on that on the CL call next week. And POTUS has a comment about this might be received differently on the CL call next week as well.
Sorry, I don't think that was what was proposed though, right? Like we were talking about the comment that Danny and I mentioned.
So
yeah, just to be clear,
yeah.
If we went down this path, almost certainly the consensus layer would want to do this path where there's the additional data in the block that's passed into the execution layer payload as an additional validation rather than peeking into the opaque transactions. And that, I think that's what you were saying, Tim. I just want to make that clear. The consensus layer does.
So what you're saying is if we go with the RLP route, there will be no RLP in the consensus
I'm getting a call from a doctor.
Yes, is what he was saying. Yes. POTUS?
Yeah, but Danny just went to talk to the doctor. But I have concerns about that comment too, and I left it in the EIP. The latency of getting the blob, even though I'm not following the testnet and it hasn't been tested, I guess, at the level of mainnet, the latency of getting the blobs is much larger than the blob. And if we're going to have to wait for the full sidecar to validate, as that comment says that we need to validate the KCG commitment against this extra field in the sidecar before using the engine to send it to the EL, then that means that we're going to be processing blocks much later. We currently can just send to the EL the block as soon as it arrives, even if we don't have the blobs, and we're gonna lose that ability. It seems to me.
Yeah, I think that Danny said in the comment. I think Danny said in the comment that it would probably be in the block peer-to-peer object, and that's what I missed whenever I said sidecar, not realizing that you have this timing issue.
If you add it to the block, then my whole complaint is not a problem. So if you just add this extra field to the block, I think I'm fine with that.
And so we definitely want the design invariant of that the block can be executed without blob sidecars.
Right, and we would, so then we're gonna go back to this thing of like being optimistic, like later on when the sidecar appears, then we could just, so if the EL says that it's all right, and we process the thing, we still need to wait for the full sidecar before putting it in Fortress.
Yeah.
With this,
but that for any design like that, that's a very important design. I mean,
that's fine.
Yeah. All right. Cool. And sorry for the misunderstanding when we were talking on the issue.
Okay, so assuming that there's not massive opposition on the CL side to this proposal, if we modify it to put it in the block, I guess, does it make sense to fully spec that out? And then in the next week, decide between either doing that, and so using RLP on the EL, SSZ on the CL, and having the hash in as part of the block that gets passed around, or we keep the spec as is, but there's no world where we do sort of the full SSZ transition right now, and we give people basically until the CL call to just review that, so that a week from now we have the decision. Or do people feel strongly enough that like we should make the decision on this now?
The sooner we can get a decision, the better.
Okay.
I don't feel strongly either way. I'm lightly in favor of what we have with SSD, perhaps extended with the signing wrapper from 6943. But I think it's more important just to commit.
Any of the client teams have a strong opinion on?
I think we've heard strong opinions in favor of RLP as well.
Yeah.
So I don't want to dismiss that.
I think sooner rather than later is, I'm also in agreement, I think, with Roberto. I feel 4844 DevNet 6 looming.
Okay, and Marius is saying showing strong support for RLP in the chat. I guess, yeah, considering this discussion sort of bubbled out of people not being too happy with the current spec, does anyone oppose if we make the decision to move to RLP now, and we can discuss the specifics of how the hash is sent on the CL call, but that we could start working on the EL clients with RLP support basically this week rather than waiting an extra week, and potentially get DevNet 6 a bit quicker with this in.
I would be in favor of that.
You would what?
I would be in favor of that.
Anyone not in favor?
If we're going to go this path, we're going to add the field to the block to avoid the dependency creeping up in the consensus layer.
Yeah.
And so I'm okay with committing to that, but committing that with the additional field.
Okay. Anyone opposed?
Were there open concerns around adding it to the block? Just wanted to, I'm not sure I fully understand the implications of that.
I don't think so. I mean, it adds a list to the block that the execution layer makes sure that that list is in accordance with the type 3 transactions, which is an additional validation, but a simple validation.
Okay, last chance for objections. Okay, so yeah, let's do it then. Move 4844 to use RLP, add the hash tree root to the blocks, not blobs, on the CL, and use this for DevNet 6. We can get some PRs stood up for all of version blob hash to the block, not the hash tree root, my bad. So add that to the block, move the EL to RLP, not introducing RLP on the CL, and use all of this for DevNet 6. Like client, you'd already started some of these PR, so if you can kind of make your draft PR into a proper PR, that would be great. And if someone on the CL side can extend Xiaowei's PR, that'd be good as well.
So I can't quite make it a full PR until we get more people to review it, because once I make it a PR, because I'm an author, it'll auto merge. So I want to make sure that
okay, fair enough.
Like it is a draft right now, but it's like ready for people to review.
Okay, good to know. Cool.
And whenever there's enough reviews, we'll merge it.
Yeah, and I guess if possible, if people could review it in the next couple of days and we can like discuss it on Monday's 4844 call, that would be great. Even if there's no objections by then, maybe we merge it. But if there are objections, at least we can discuss those on the call Monday. And Terrence asked the question, is anyone working on the CL side? So Xiaowei is the one who opened the PR that like client commented on, but I don't know how final or like production quality that PR was.
That PR is no longer valid, because that PR imports an RLP library to do the decoding rather than the version that we're talking about. It's relatively simple. Probably myself or Xiaowei can handle it. I'll ping her and we can chat about it.
Okay, cool. Awesome. So yeah, we're doing your RLP for 4844 and saved ourselves another 2+ week of discussions on this. So nice. Anything else on this? Okay, next up, Mario, you wanted to chat about an issue that you opened in the EIP. I did not have time to read it before the call, unfortunately. Do you want to give some context on it?
Yeah, it's a very simple issue. It's related to the version hashes on the 4844. Basically, there's a discrepancy between the interpretation of the implementations. So in the EIP, it mentions that the only reason to consider a block invalid during block execution is that the blob version hashes, the amount of blobs is 0. But some implementations are also checking the blob commitment version of the blob transactions. So basically, what I would like to do here is just to add a clarification in the IP, because my understanding is that the execution can proceed and is valid even when we have an incorrect commitment version in any of the block transactions. But most of the implementations right now are rejecting these blocks. So yeah, basically it's just I would like a clarification of this in the EIP for us to get the correct version I mean, to get the correct idea in the tests, basically. And to add a little bit more context, I'm implementing the Go Ethereum current implementation does not check the version, the byte of the commitment version. Nethermind does check this, and Ethereum VAES does check this too, if I understand correctly. And the tests right now do not care about this byte on the execution client, on the execution payloads. So yeah, basically that's about it. I don't know if anybody has the time to review the issue, and we can just come to an agreement whether this is recorded or not. It will be great.
Anyone have thoughts or comments? Gajinder has a. Oh, actually, Gajinder and Alexei have a +1 on always requiring the version byte in the chat.
So one thing that I like about requiring the version byte is that no one can update the version without also updating the client. And that means that updating the version byte would be a hard fork, which it should be, in my opinion. So I'm all for requiring.
Cool. Anyone against requiring it? Okay. So I guess we can do that. Does this, I assume this requires a change to the spec, to like basically to 4844, and then we can write some tests for it?
Yes, I can open a PR just to make the small change, if that's okay.
Awesome. Yeah, that
and
would be
change
great.
the test also. Mm-hmm. Okay. Thanks.
Sweet. Anything else on this?
This might actually issue like one of the issues that we saw on DevNet 5. So my fuzzer most likely sent transactions that did not have the version byte correctly set, and so that's probably some of the breakage that we've seen.
Got it. Anything else? Okay, if not, okay, so this next one, Peter, I saw you posting about the KZG libraries a lot on the Discord in the past week or two. I just wanted to check in on that and see, is there anything on the library side that like we should be doing or working on, yeah, to make sure that they're in a good spot for us to use in production. If there's like nothing new or anything, nothing you want to bring up, we can go over it, but I just wanted to make sure we have the chance to check it on it.
Yeah. So essentially, with the KCG libraries, there are certain quirks that are kind of unexpected. The CKZG library, specifically the BLST sublibrary of it, has an interesting aspect. It has some optimizations baked in that require fairly modern CPUs, and it will pretty much crash on an older CPU. Older CPU, basically any CI server will crash. So not older, by older CPU, I don't mean ancient CPU, I mean just not the newest and greatest. And the problem with them is that they have a build flag through which you can control whether to enable this optimization or disable it. But the author refuses to implement a runtime detection. I mean, it would be probably trivial to do it, but for whatever philosophical reason, the author just doesn't want to do it. And this makes it particularly hard to integrate into other clients. I mean, pretty much every consensus client had already issues with it, as far as I know. And they had to, I mean, even if you look at Lighthouse, they have a modern build and a portable build, which is basically boils down to the CBLST library. So screwy details. Now, the problem, the other annoying problem is that since you require an environment variable set during build time, it doesn't really play nice with using it as a dependency. And for example, because in Go, the Go build system is very simple. You just type Go build, and all of a sudden, if you want to control the C library and make it portable, then you cannot do that with the default Go commands. You have to set an environment variable, which means that anybody building Geth all of a sudden has to know about this lame environment variable, and if they don't know about it, then there's a fairly high chance that their build will crash at some point. So this is one of the really annoying issues with the CKZG library. With the Go KZG library, again, not the Go KZG itself, rather the upstream, I don't know, one of the consensus crypto libraries, it makes some strange optimizations. It does a lot of stuff concurrently, and this concurrency cannot really be controlled, which is a bit of a strange decision for a crypto library, because it's, I mean, for example, it can verify a blob concurrently on many threads, and on default it will verify it on all your threads. And I mean, for sure, it's 3 times as faster verifying it on 20 threads, but then the question is, that feels a bit of a wonky trade-off to be 3 times faster on 20 threaded loads. And there's really no way to control this threading. And I would much rather have a crypto library be single-threaded and dumb and let me do the concurrency by verifying multiple blobs on different threads rather than the crypto library internally deciding on what to do. I did look into it, and it's a fairly ugly internal design decision. So yeah, I guess, again, with some flags, you could maybe, and with some modifications, completely nuke it out somehow. I don't know, it's a bit wonky. Anywho, so these were my two main concerns with the 2 crypto libraries on top of which the KCG stuff is built. Just for the record, with Geth, what we did is we integrated both libraries, both GoKCG and CKCG. We default to GoKCG. And with regard to CKCG, what happens is that if you build Geth via make or the Docker images or our own internal build scripts or pretty much almost anything except the classical Go build command, then Geth will add the flag to enable CKZG and also add a flag to make it portable. So that's the default. So all of our official builds will support both KZG, Go KZG and CKZG. You can switch between them with a flag, but anyone building Geth via a simple Go build or Go install command will not have CKZG available. So that was kind of our best idea on how to solve it. And for us, it was, in all honesty, we have a fairly low level of trust in both KZG libraries and the underlying crypto libraries, because it's kind of new, and we have an equally low trust in ourselves to fix any issues if they happen. And that's why we went with this approach of including both of them and making it switchable via flag, because for sure we prefer the Go version. But if there is let's say, an issue, a consensus issue between them, then we want to be able to have users switch immediately without having to figure out, okay, how do we swap out the library? How do we enable it? How do we integrate it, etc. So yeah, that's kind of the TLDR of the KZG saga that we had on the GET side.
Thanks for sharing. I noticed there was a couple comments in the chats during this, but anyone have thoughts or anything we'd like to add there?
Yeah, we at Nethermind, we can solve it by runtime selection of the library, but it would be better if the library could support runtime flag instead inside it. So we need to know whether we need to invest in this additional build and runtime check, or we could wait for a solution in LST.
POTUS?
Yeah, so as one of the ones that complained about runtime selection on BLST, the problem is the way this is coded is not that you have one routine that uses ADX and MULX and another routine that doesn't. They're just bits and pieces that are added or not by preprocessor instructions. So I think the only feasible way of changing this without big changes within the library is what the people of Nimbus were going to do, which is just disassembly with the flag, disassembly without the flag, have the full binary ones, and just choose at the beginning. So have a much larger library with 2 copies of the full routines with one flag and the other flag, and then choose on runtime. That would be their fork. And I don't see any other easy way of doing this change, making this change in BLST. So I don't expect the author to actually accept a change towards this anytime soon. And this is really annoying. This is something that really annoys me, because it's something that the Ethereum Foundation paid for this library, and every single client complained before the launch of the Beacon chain. And this wasn't solved, and now that the execution clients are also complaining, that it's getting some traction again. Yeah, so this is something that is incredibly annoying on the CL side. At the point that Prism is shipping this this binary by default, which is portable, because we did see some crashes. A lot of validators are being run on AWS currently, and they do crash because they run some old Xeon CPUs. The other comment I wanted to make, which is something that makes me uncomfortable with the status of the crypto libraries, is that they are still changing quite a bit, and in things that are kind of non-trivial. On CKCG, I saw Marius that was complaining about the way of loading the trusted setup. And on the Go KCG side, it's something similar. Like the version that we were trying did not accept the trusted setup that is posted already in the consensus layer spec repo. And the change that fixed this is not long ago, which means that if you update the crypto library to use that change, then you need to update Get, and Get hasn't updated to this. So it's becoming very problematic with all of the relations of the different clients with the crypto libraries to even start testing this. So I think we're still at a prototyping stage. I would say that we're very far away from developing production code in that area.
Thanks. Solius, was your hand up about this as well?
Yes. So a few notes on this. So on this extension thing where you need to compile the thing with basically with either for new CPUs, either for old CPUs. I think we also discussed internally an interesting approach, but it's probably similar with the Nimbus one, where we just in the runtime essentially we compile both versions of the BLST library with enabled extension and with disabled extension, and then on the runtime we check what CPU is it running, and if it's a new CPU, we use one version, and with enabled extension, and if it's not running, and if it's running with old CPU, then we are taking the old library. I think this is an ugly approach, but at least you would not need to to have a separate builds of your client. So, but this is probably similar with what Nimbus was thinking, isn't it? The approach that Potus was talking before. Anyway, so this is one question. The another question on the parallelization. So for REST KZG, we have even much more, let's say not much more, but more parallelized version where we make verification faster. But the problem actually is not about using a lot of cores, because if it's available, then why not use it? But the problem is that if it starts to compete with something else that client is doing, something else important that client is doing. So my question is for original person who raised this question, like how do you deal with this elsewhere? You should have some hard computation that you already parallelize, and how do you prioritize it? And like if you could tell some examples of that would help to make a solution that hopefully some built-in solution in the crypto library that helps essentially that solves this competing problem. So one way we are thinking about is just to lower the thread priority, essentially. So the OS operating system scheduler will just make it less competing with other things that client is doing. So, I mean, if you could tell how do you solve that currently, because you talked about that you don't have control in this approach with crypto library. But if you had control, how do you do that?
Well, I think one of the problems is that this is not solvable at the crypto library level, specifically because, for example, if I'm doing a block processing, then I don't want it to be a lower priority. Then, for example, if a new block arrived, I want it to actually have the highest priority during processing. Now, if on the other hand, the blob is being verified in the transaction pool, then, for example, I would like to have it a lower priority. So these are, and this is something that you, from the library, from within, you cannot really guess which blob is important now and which blob is not important.
So, yeah, I think a pretty easy approach would be, I mean, not ideal, but something that would be easy to achieve is just to set the thread priority whenever you call the verification function, So if you need that as as fast as possible, then you say that the crypto library should spin threads for this particular verification with normal or high priority. And if you, otherwise, if that's not important, you just say for crypto library that this is not important verification, and it just spins threads with lower priority, so it doesn't compete with things that with everything else that runs on the default priority at your client. Does this make sense?
Yeah, sure, it does make sense, but
I mean, there is no easy solution for that, but there are some solutions that probably should work most of the time. And the one I just described, it could be the solution for this problem.
Sorry to interrupt, but just to make sure I understood, you want to have a specific thread scheduling policy for every use case, and it will have, because it's dependent on what OS you're running on, you will have to have an OS like specific library for every platform you want to support, basically.
I mean, we checked on the three main platforms, which is like Linux, Windows, and OS X, and usually there is a way. At least for these three operating systems, there is a way to change the priority of the thread. So this pretty much is enough to implement this idea. Maybe for other platforms, which we were not interested in, maybe it's even not possible to change the priority. So then, yeah, this doesn't work on those platforms.
So I don't think that will work, for example, in Go, because Go doesn't have real threads. Go uses very few real threads and multiplexes all the Go routines on top. And I don't think you will have a way to lower the priority of a thread of a Go routine.
But if you, so I don't know actually how it works. Like if that's only Go environment, then yes. But if that's something external, something like if you call C KGD or Rust KZG from Go, then it definitely should be able to use system threads, because it's like C extension or something outside of the Go thing.
That would be super expensive, because spinning up threads is at least on Windows, on Linux, it's a bit faster spinning up threads, but for example on Windows it is extremely slow, on the order of milliseconds. So if your crypto library will spend 10 milliseconds or 50 milliseconds spinning up threads to do the half millisecond work, then that doesn't really fly. So essentially these are kind of also, this also highlights the issue that once the crypto library is a very, very low level stuff, and it tries to do threading, which is a very, very high level stuff, and then you hit all these kind of strange issues with how to solve. So it just feels that a crypto library should not touch threading.
Yeah. So we're
well, I think. Yeah, just last note. I think we just really need to think: do we need like a top performance, or we can go on a single thread and everyone is happy with that?
So I mean, I just want to chime in here. I've been trying to get in for a while, but I think like the only thing where threading even makes sense is for blob construction, and I think we're getting way ahead ourselves by trying to optimize this now. Like, I think it's perfectly fine right now to just completely ignore this, because the kind of like rollups who are going to do blob construction, it's still, first, it's not a lot of time. It's still talking tens of milliseconds here. And second, like, they can start optimizing that. They don't even have to use a standard build for that. So I feel like trying to optimize this now is just like, I would just say, like, we don't need threading at the moment and can just ignore it, and maybe can have it somewhere in the code, and they can have a special build or something.
And do we have like is there a decision pretty close to finality how much of blobs there will be in block on the mainnet? I mean, is it like 4 or 16?
What does that have to do with it?
Well, like on CL side for verification, it's
for verification. Why do we need parallelism? Like, this is like, we're talking about like a few milliseconds.
Well, but there are a few things. There are slow computers, like slow nodes, where every millisecond just multiplies by the slowness of the computer. This is one thing, and there are some use cases where block verification is important, like every millisecond is important, like in MEV or whatever else domain. So I actually don't agree that that you can just ignore the fact that those milliseconds adds up together. And if you have 16,
I mean, this is on CLR,
blobs,
right? It can be done in
yeah.
parallel to execution layer verification anyway. So how much does it actually add?
Sorry, could you repeat?
This is in parallel to execution layer, like this is a CL thing. So it would be in parallel to what the execution layer does anyway. So does it actually do block verification any faster if you parallelize it in CL?
Sure, and why it shouldn't be faster if it's
because
not?
Because I would assume that EL is the bottleneck anyway. So if you add a few milliseconds on the CL, it wouldn't matter.
Okay, so you're saying so your point is that that CL will always be significantly faster than EL, so it doesn't matter that if it's lower on the CL side, yeah.
I mean, this would be my guess right now. Again, I also feel we're getting ahead of ourselves optimizing this for someone who's doing MEV extraction. Like,
okay, so I mean, I'm still with my opinion that we should do as fast as possible. But yeah, I get your point that if EL is much slower than CL, then technically we shouldn't have the problem here, because CL will be able to complete even on a single thread verification because EL is taking much more time. Okay,
also, like, I mean, the CL can parallelize other tasks in parallel to this. So, like, I would assume that signature verification is much more work, but you can easily, like, the CL can simply, thread the blob verification, the signature verification. Again, this feels like absolutely optimizing the blob verification to like 16 threads just seems crazy to me. Like, I mean, I don't know, like that seems like an insane premature optimization that's like just makes things more complicated.
Well, I think that the key thing on CL is that the blobs will come asynchronously, not at once. So naturally, like the proper implementation is just to do verification whenever you get the blob immediately.
So that would be an even stronger reason not to parallelize it.
No, I think well. But if you have a lot
so
of
why
cores,
are we even discussing this? It just feels like a waste.
Yeah. So I guess
but that was a bit of topic to the original questioner, to the original person.
So we're already like 5 minutes over time. I don't know. I know there's a Telegram channel discussing the libraries. Is that the best place to just? Actually, the Telegram channel is like for CKZG, but is there somewhere that we should continue this conversation? I mean, we can use the, like we have a bunch of 4844 channels, so we can use those. Yeah. I don't know if there's any final comments before we move this offline. Okay. Yeah. So let's let's continue. Do you mean, Alexa? Do you mean SSZ chat or KZG chat?
No, it's by the way now. Always wanted to have SSZ separate chat in Discord.
Oh, okay.
Discord.
We have a transaction type channel, which I think we can probably reuse for that. Yeah, we have a type transaction channel, which we used for that in the past. So you can just keep using that. Yeah. Okay, so we're already a bit over time. I know we had Zach and Charles who wanted to like give a bit of context on their EIPs. We can take 2-ish minutes on each of them if folks can stick around. If either of you, Zach or Charles, prefer to do this on the other call or on the next call with a bit more time, we can do that as well. But if not, Zach, do you want to go first and give some context?
Hey, Zach Cole coming at you live from left field. Just coming to discuss EIP 6969, and I guess out of respect for time, happy to punt this to the next call. But is this the best forum to discuss it, assuming that this EIP targets specifically L2 implementation? With that in mind, there's a caveat that it does involve additional state transitions and may have implications on supply as well, since it's a modification of 1559.
So yeah, we haven't. Dano had some comment about this on the chat, but like L2s can do things without Alcordev's, permission or authority or a way. If people have like technical feedback on the EIP, it probably makes sense to share it. And I know there's already a bit on ETH Magicians. Yeah, anyone else have thoughts on either the EIP or whether we should even be discussing it? Dano?
So to add on to that, about the jurisdiction, I mean, if we say something and the L2s ignore us, there's like no side effect, versus if something for mainnet, something decided on this call and say Geth decides not to do it, or the non-mine decides not to do it, well, they're out of sync with mainnet. So there's a bit of jurisdiction because we define what's standard, but L2s can do what they want. I mean, it's so that's my concern, is that there's no stick, just carrot.
Yeah, I think maybe one difference is, and this is maybe not the best EIP for this, but you could imagine L2s wanting to do something before mainnet and wanting like some sort of sanity check of like, if this goes well on an L2, does L1 want to do this? So that might be a case where it makes sense to get the feedback earlier rather than later.
And I do see that this IP might have that along with other ones like 4337, and maybe in the future EVM changes. So that is a question we need to resolve, beyond just this EIP.
William, you have your hand up as well?
Yeah. I wanted to add a point similar to the one you just made, Tim. So, I mean, full disclosure, I work at Polygon. A lot of times there's a certain level of coordination that I feel ACD should be open to, though, I mean, there's an opinion, definitely open to debate. I understand your point, Dano, and I think that it does, like, there needs to be some kind of resolution to that. But looking at an EIP like 3074 or other ones that involve actual EVM state changes, I think that there's a lot of value in a certain level of coordination effort going through ACD, even if it's not necessarily going to land on Ethereum's EVM right now. It is the best rallying point around EVM engineering. And like Tim mentioned also, just being able to get some level of sanity check that things potentially make sense, or also to be able to send signal, I think is valuable. I think there's also a value to that for Ethereum itself, which is that L2s have much more of a potential, or alt L1s, for experimenting with things that Ethereum probably should not be experimenting with. But if are successful on L2s, can kind of trickle back up to Ethereum. So I think also kind of in that cycle, there's at least some value there, but that's just my side of things.
Thanks for sharing. Ansgar, last comment on this, and then we'll move on to Charles.
Yeah, I just wanted to very briefly say, because I've talked to some people about similar ideas in the past, but I do think it makes sense to have some sort of coordination between alt EVM chains, including layer 2s. I'm not so sure that, at least in the long run, ACD would be a good forum, because we can never actually promise to bring things on mainnet, right? It could always be that even if we think we might do it, then we later on decide not to do it, and so then I think in the long run it makes sense to have these kind of processes be separate, although I wouldn't be necessarily opposed to use ACD in some form for bootstrapping a process like that once there's sufficient interest. But yeah, we just should continue this discussion somewhere else.
Yeah. Yeah, and so I guess for the specific EIP, we can use ETH Magicians. And for this like meta discussion, I agree this is probably something we need to figure out. I'm not quite sure what's the best way to have that conversation, but it's been on my mind as well. I would definitely want to avoid a new permanent call if we can for as long as possible. Yeah, but let's see. Okay.
One more.
Yeah, please, Zach. Yep.
I'm sorry. Just one more thing. Is there any way that we could just get this EIP merged so we can alleviate any bottlenecks from the active working group? Sorry if that's not the best place to ask. But,
So I know there was some issue with the numbering. I think it's probably easier to resolve those on GitHub or Discord and not open that can of worms here. Yes.
Sounds fair. Thank you.
Yeah. Yeah, and sorry for the delay and sort of jamming this right at the end. Okay.
No problem.
Charles.
Hey, I know we're really over time now, but I wanted to bring up again mcopy and secondarily pay, which were brought up last time. And I think at the time Tim said that, you know, to give everybody a bit of time to review it. And I was wondering, I'm happy to punt to next week, but, you know, I wanted to keep asking if we can include at least mcopy and also pay in Cancun.
So I guess we definitely shouldn't be making this decision 15 minutes over time. It seems, so there was some like support for mcopy last time. It seems like there is in the chat still. Maybe, and then pay opcode's a bit more controversial, it seems. Maybe what we can do is like put mcopy on the agenda for, and we can put pay as well, but like put it on the agenda to make a decision about on the next call. So like 2 weeks from now, we have an idea, and generally as well, try to figure out if there's other smaller EIPs that people want to see in, because I know like 4788 or the BLS precompiles were also kind of wanted. So if client teams can have like an idea of which small EIPs are important and would want to be included in Cancun by the next call, we can have that conversation.
Okay, great. I do want to point out that EVM1 did merge support for mcopy. I think they're also working on state tests, and there was also an open pull request on Geth for mcopy,
Nice.
which I think Gumbo and like have already reviewed. But if one of the maintainers wants to at least, you know, not necessarily do a full review, but at least take a look at it so they can get an idea of how nice mcopy is and how useful it is, and it's not too hard. So I think that might help a little bit.
Awesome.
But anyway, yeah, we can continue next call.
Cool. And I think this is a good spot to end. We're already 15 minutes over. Anything final anyone wants to bring up before we wrap up? Okay, well, thanks everyone. Talk to you all on the CL call next week.